For our next exercise, we're going to be looking at isomers. We are going to examine this molecular formula, C4H8O2, and look at some of the possible isomers that can be found using this formula. The first thing that we want to do when trying to find isomers using this formula is to determine whether or not there are any double bonds or ring structures in this molecule. To do that, we are going to calculate the index of hydrogen deficiency. To calculate the IHD, we are going to ignore these oxygens, if you'll remember that oxygens have no effect on IHD. So we're going to look at this as a C4H8. Now, we're going to compare C4H8 to a normal alkane having 4 carbons, which would be C4H10. So in order to calculate the IHD, we have IHD is equal to the number of hydrogens in a normal alkane minus the number of hydrogens in our molecule divided by 2, which is equal to 1. So that tells us that this molecule has to have either one double bond or one ring structure. Okay, now we're going to work out an example. The first thing that I want to do when working out an example here is to figure out what my backbone is going to look like, my carbons. So I know I have 4 carbons. So let's just draw a simple 4-carbon chain. Okay? Now I want to place my oxygens. I can put the oxygens pretty much anywhere I want to, but for this example, let's put an oxygen here and here on the same carbon. Now I know I have to have one double bond. So for this purpose, I'm going to put a double bond here on this oxygen and add one of my hydrogens here. Now if you'll refer to table 2.3, you'll see that this is a carboxylic acid. The next thing that I want to do is make sure that I have 8 hydrogens. I put one here on this oxygen, and I have these 3 carbons. This first carbon is going to have 3 hydrogens on it, and each of the next 2 are going to have 2 hydrogens. That gives me 7 hydrogens plus the one here makes 8. So I know that this molecule has the molecular formula of C4H8O2. Now what I want you to do is to open up your book to table 2.3 and look at some of the different functional groups and determine which ones you think would be possible in a molecule with the formula C4H8O2. And then we're going to look at some other examples using those functional groups. Now we're going to look at some more examples of molecules with the formula C4H8O2. The first one we have here is the example we just looked at. Down here we have a molecule that has a ketone and an alcohol. Now remember, we have to have either a double bond or a cyclic structure, and we have one double bond here. This next molecule is an aldehyde and an alcohol with one double bond. And here we have a diol and an alkene. So we have one double bond again. Now all of these have the same basic 4-carbon straight chain structure that we talked about earlier. But we can also have a ring. We see here, this is an ether. It has an oxygen as a part of the ring. So we now have a 5-atom ring instead of a 4-atom, and an oxygen. So there's one ring. We have a diol here with a 4-carbon ring. We have a diol with a 2-carbon ring, or a 3-carbon ring. And we look over here, and we have a 3-carbon ring with a ketone and an alcohol. What's wrong with this molecule? Now remember from our IHD that we have to have either a double bond or a ring. In this case, we have both, which means that this is not a correct structure for the formula that we drew. In order to correct this structure, we could do one of two things. Either we could erase this double bond and put a hydrogen in, or we could have gotten rid of the cyclic structure. When we look up here, we have another carboxylic acid, just using a different skeleton, a different 4-carbon skeleton. For the last two, we have esters. Now, an ester is similar to an ether in that it has an oxygen in the middle of the chain, but it also has a carbonyl oxygen on the adjacent atom. And we can place this in two different places here, so we see two different structures for an ester. And that is some examples of isomers with the same molecular formula, C4H8O2.